Welcome, everybody. I'm Ara Bagdasarian, the co-founder of Omnilert, and we're welcoming you today to learn more about Omnilert gun detection and demystifying the technology and giving you a good picture of how it works and why it matters. All right. To get started here, I want to introduce my team. We're going to hear from Chad Green, who's the Director of Artificial Intelligence, Eric Polovich, Director of Sales Operations, and Dr. Kevin Eberle, a school safety expert who we connected a few years ago with Omnilert, and he'll share his background in law enforcement and school administration with you and really give you a perspective that he has that I think is quite unique and why AI gun detection with Omnilert is such an important tool. And to give you background on Omnilert and what we do, why we do what we do, our mission is to protect people by developing advanced public safety technology and delivering the most reliable and innovative safety solutions. We empower communities to detect threats, respond faster, and prevent harm before it happens. And you're going to see the recurring theme throughout this program is prevention. Omnilert started, Eric's going to probably talk a little bit more about this, 20 years ago. We created the very first mass notification system, multimodal mass notification system, to address critical communications. If there's an emergency, how quickly can we communicate to the masses via all communications possible? And we've continued that legacy through today and constantly innovating. We launched Scenarios, which is an automation tool, which Eric will talk about a little bit more about how after detection is made, how do you handle things after the detection through automated workflow? So all these things do tie together. But to get things started off, we'd love to introduce Chad Green, our head of AI. I mean, it's really incredible the work that he's done and how and why we got to the gun detection technology that we have. So, Chad, please.
Thank you. Thanks, Ara. Well, yeah, my name is Chad Green, and as Ara said, I'm the Director of AI for Omnilert. Before I jump into what Omnilert's gun detect is, I just wanted to give you a brief overview and some background on where this idea came from. So I started my career working for the Department of Defense and focused mostly on optical sensors and optical sensing techniques. So there's this one project in particular that really kind of set the trajectory of my career, and that was this DARPA project that started back in 2004 when we were in Iraq and Humvees were getting blown up by these simple rocket-propelled grenades. So DARPA back then asked if there were any technology providers that could offer a solution to this. As RPGs are very cheap, they could get them from the black market for just on the order of $25, and that cheap munition could actually take out a tank. The jet that comes out of a rocket-propelled grenade can penetrate up to 1.5 feet thick of steel, of rolled hard armor. So it was a very difficult problem, and it's compounded by the fact that there are so many different types of RPGs out there. And all of them, some of them have multiple warheads. They're all just a little bit different. So to detect and track these and hit them precisely was a super challenge. So a false positive in this case, if we were to allow an RPG to come through our system, then the truck's going to get destroyed. A false negative, where we say, well, that would be a case of a false negative, where we said there's no threat here and the threat hits us anyway. A false positive would be a situation where we said there was a threat, but there actually wasn't a threat. And in that case, an explosive is happening outside the vehicle and somebody could get hurt. So not only is it a challenging detection situation to discriminate all these different targets, each one of them having a warhead in a slightly different place, and we're trying to destroy the warhead with another explosive, but it's also a safety critical system, and we had to pass it off by the Army Fuse Safety Review Board. Actually helped with the design of the electronic fuse that was used in the system, which was novel in this case because it both arms and disarms, and that's not a thing that you do with munitions. But it was a huge challenge. And while I was doing that, well, let me just explain how the system worked a little bit. So we're on light armored vehicles that don't have a whole lot of armor. So they're easily destroyed by chemical energy weapons. So we would scan the air for threats in the air. And then once we detected something in the air, so we're filtering for things in the air. Once that filter was passed, then we're looking for threats right by our vehicle. And that's where my vision sensor would work. my system was looking from the top of the vehicle down and scanning for things that are right next to the vehicle. And then we'd have to determine what type of threat that was. Since there's a different aim point for each of those munitions, we'd have to figure out precisely where to hit it and time a counter munition to hit it right in that aim point. So it's sort of a three-step process: assess, detect, analyze. So while I was working on that system, well, let me just show you a few highlights real quick, just so you understand the scope of this issue. Eric, I might need you to click play for me on that slide. Thank you. So this is a rocket approaching our test system. And when we detect it, then we fire a munition down from the top and we destroy that rocket. So it looks like it's exploding. It's actually not. That's called a deflagration, where the explosives inside the rocket are burning rather than detonating. But in order to detect this thing, we use computer vision. We had to look at the shape, color, profile of the rocket and decide, well, is this a Russian rocket? Is this a Chinese rocket? An Iranian rocket? And depending on how we classified it, we had to select a different aim point. Okay, so moving on. While I was working on that, the tragedy at Sandy Hook happened. And this is actually hit very close to home. This is my cousin's daughter, Emily, who was just 6 years old at the time. There were 20 students at that school that were killed and 6 adults. And it made me rethink my priorities a little bit. It's been spending most of my time protecting soldiers. And I felt like at that time, I needed to get more creative and focus my time on protecting kids in schools. So what we want to do is create time, create awareness, and give schools, communities, and organizations a chance to act before lives are saved, lives are lost. So the idea was that schools already have surveillance cameras installed. In fact, there's about 85 million surveillance cameras across the US. However, less than 1% are actually monitored. So these cameras are just used as a forensic tool. After something bad happens, we go back and we look at the tape. But what if these cameras could be used as proactive tools, as actual detectors? So you can do that by having somebody watch the camera feed all the time. But humans get really bored. After just 12 minutes of watching a video feed, they can actually miss 45% of the activity in that video feed. Now ask them to monitor more than one video feed. 95% of the activity would be overlooked in just 22 minutes by a human that's watching these cameras. So since I had experience in computer vision, my idea was to use computer vision to try to find weapons in these surveillance cameras. So how does an AI video analytic work? And this is where we want to try to demystify a little bit. When you hear AI, you probably think of ChatGPT, you think of image generation and these really fun tools that we have these days. Well, AI is a method of creating a filter. AI is a method of doing a mathematical process through learned data rather than handwritten code. So I'm showing in here in this slide a surveillance frame on the left, and then a convolutional neural network is being depicted by the 3 filters in the middle. In a convolutional neural network, this is the backbone of a lot of AI detectors. It's a really interesting filter, and it has layers. So on the first layer, it might be detecting edges, colors, basic shapes. But the convolutions are actually able to stretch the RGB space into more dimensional space, where it can actually find and filter things that are more interesting. So the middle layers of the convolutional neural network are able to detect more complex shapes, like parts, like the ears of a cat, the fur, and be able to determine, oh, this is a cat versus a dog. And then deeper into the neural network, it's able to discriminate objects and classify things into categories like person, car. The ImageNet competition in 2012 had a data set of 1.2 million images and over 1,000 objects that needed to be classified and detected in that competition. And there was an architecture called AlexNet that was a breakthrough architecture that used machine learning and a method of training that neural network to set those filter values automatically through training, instead of having an engineer design the filters manually and all the parameters, which is very, very difficult. Earlier attempts at the ImageNet competition actually started in 2010, and some of the engineers tried to use manually set filter values in order to win at that competition and failed. But it was when we learned how to train neural networks that AlexNet was a big breakthrough. And since then, we've come up with many, many different and newer computer architectures for feature detection. And we've built on top of that feature detection to not only classify objects, but find their position as well. And that's called an object detector. So on the output of our system, we're not only classifying objects such as rifles, handguns, cell phones, and other things, but we can tell you where it is in the image as well. So these filters are important because for any human to monitor, let's say your organization has 1,000 cameras. To ask a security guard to watch all those 1,000 cameras is an impossible task. But with a very well-trained convolutional neural network, AI-based detector, one person can easily monitor more than 1,000 cameras. In fact, we have customers with over 9,000 cameras. And since we're filtering for only the objects of interest, such as handguns and rifles, a very small team can monitor all those cameras simultaneously. So it is a force multiplier. It allows the small team to go about their daily lives, their business, but just be on alert for when something of real importance is available to look at. What we're trying to do is improve the timeline, because on average, an active shooter situation takes about 8 minutes. But the tragedy is that sometimes it takes up to 5 minutes for 911 just to be called. That's an average number. And you can imagine, that sounds like a long time, but you can imagine being in a situation like this and hearing what sounds like a gunshot, but not being sure if it's a car backfiring, looking around you to find out how other people are reacting. It actually takes time for people to gain that situational awareness. If you're a security guard on the site, now you're on the radio trying to find out from your team what's going on and trying to communicate about that situation in real time. With the filters that we talked about, where only very important events are coming to you with information, and that information includes a full frame image to give you the context of what the camera saw, a zoomed in crop of the person and what they were holding, plus a short video segment that's annotated with a red box around the object that was important to give you that temporal context. Everybody receives the same information at the same time, and they can all respond together. So if we can get behind shots being fired, behind the timeline, those critical seconds, critical minutes can help save lives. Not only that, but it can help coordinate the response. So what happens after the detection, I'm going to allow Eric Polovich to talk about, but we follow the same process that I did when I was trying to detect rockets in the air. So we assess the situation, we look for objects of interest such as people, and then we look within, we crop the image of the person out and then give that high resolution person image to our detector to filter for weapons. So once we have the weapon and we know the position, we can also run our analytics on top of the AI. So we never let the AI make decisions on its own. We have our own custom heuristics and analytics that we've developed to make sure that we can watch multiple frames, make sure that we don't have spurious detections, watch how the weapon moves, so that our probability of detection stays very, very high, and the rate of false alarms or spurious detection stays very, very low. Once we have a high confidence detection, then we can hand that off to, I'll hand it off to Eric to explain what comes next.
Okay, thank you, Chad. Before I go to Eric, I've got a quick question for you. I know somebody asked a question beforehand that since you developed the technology years ago after Sandy Hook, there have been other technologies that have emerged. Are all the AI gun detection technologies built on the same technology, or are there variances in that?
They're not all the same. And AI has evolved quite a bit. So there are convolutional neural network-based detectors. There are newer neural networks called transformers. ChatGPT and those type of interactive chatbots are based on transformers. There are diffusive networks to generate images. All of them have their pros and cons and find a place within the system. What we want is very highly deterministic systems. For example, when you put an image through the system once or twice, you want it to get the same answer. So when we have a detection out in the field, we can play that detection back through our system, and we get the same answer that was gotten out in the field. That lets us analyze and figure out what happened and improve the system iteratively. So deterministic systems are very important. We don't want the system to hallucinate. This is a safety critical technology, so we want to make sure that it does the same thing every time.
Okay, awesome. Thank you. And thanks for the explanation and how the system works, or the why and the AI. Now, Eric Polovich, would love for us to give us a tour of how it actually works, because I'm sure that the folks that are attending would like to actually see the technology and work.
Eric Polovich, I've actually been with Omnilert for not as long as Ara has, but 17 years. And I've been talking about Gun Detect since before we launched it back in 2019. And our system is an end-to-end process. Chad talked a lot about the artificial intelligence that detects weapons, but that's not the end-all be-all. We're not simply saying, hey, there's a gun here. We're taking action, and that's a big part of it. It is a end-to-end workflow that is built to uplift existing security teams. And this workflow, of course, starts with detection. It's those blink and you miss it moments using that advanced artificial intelligence that Chad and his team put together. It is about getting the gun, whether it's flashed out of a pocket, transferred from a locker into a backpack, pulled out of the trunk of a car, and concealed underneath a jacket. As he mentioned, we're looking for not just weapons, but a lot of different profiles, handguns, long guns, cell phones, water bottles, torque wrenches, like you see here, a number of tools, benign objects that could be confused at a glance with a weapon. Thirdly, our multi-step detection algorithms taking context into account. We're not just looking for things in space that look like a weapon for a frame. We're looking for a vector over a number of frames that weapon is consistent, and it is consistent in the way that a weapon acts. That's when we make that detection. Now, that detection is just the first part of an end-to-end workflow. We very quickly get that information in the hands of people and systems that can do something about it, take action, validate that this needs action, and then execute. And it starts with our validation. Human-in-the-loop verification is very important. I think IBM said it best back in the 70s, you wouldn't let a computer make a management decision because a computer can't be held accountable. We feel the exact same way here. It's about getting actionable items into qualified professionals' hands so that they can make a decision. Now, the first stop along that path could be a number of places. About 95% of our customers go with Omnilert monitoring. That's going to be a series of geographically dispersed, technologically redundant central stations, for lack of a better term, that can verify a detection and then move it along the chain of command. But we also support direct-to-security operations center integration. So we can put it on your video management system, on your video wall, inside your image system, or other control room platform. We can put it directly into a third-party monitoring facility. Don't want to go with Omnilert? Have a team you've been working with for years? We'll facilitate that through our verification API. We can even put it directly into the pocket of your team, utilizing our Omnilert mobile app, giving you that information, that context, the same information we're going to give over to the professional validators, those images, a zoomed image for detail, a video for context, as well as the location and responses so that you can take action from wherever you are. As I said, about 95% of our customers go with Omnilert monitoring for a number of reasons, but one, it is a professional team of validation staff that work with first responders on a daily basis, and they're working 24/7 verifying and moving things along, facilitating that communication with first responders, working with our customers' teams to make things happen. We work with a partner for this. It's a company called Noonlight. They're a division of Alarm.com. We've been working with them for years, and they give us great performance. In 2025, our detection average in the field is less than a second. Our verification by the monitoring staff is less than 10 seconds, which means end to end, when a weapon appears in front of a camera, they're taking action less than 10 seconds later on average. And that action can include escalation to first responders via a direct connection, programmatical connection to public safety answering points, the same place that 911 calls come out of, which means that rich, robust data, those images, those videos, that location, and that cool, calm professional on the other end of the line are right there, making it to dispatchers, making it down into in-car systems and mobile terminals. It's not just about babysitting the AI. It's about facilitating advanced escalation. Now, we can also put it, as I said, directly into control rooms, whether that's instead of or in addition to our Omnilert monitoring teams. That means we can drop it onto a VMS, put it into that security operations center, allowing them, when a firearm is detected, to take action, pushing it back into those control room platforms, using their bookmarking and alarming capabilities, setting off subsequent integrations, serving up that image, those videos, in addition to facilitating additional integrations through Omnilert. We've been communication experts for 20 years now. That activation phase, after a human gets their look at it and says what's next, is just as important. Integration is what we've been doing for a long time. Locking doors with access control, raising the alarm with integration with security systems, getting the word out through integrations with not just the Omnilert notification platform, but other notification platforms, in addition to first responder integration. It's about pushing out a unified response in response to seeing a weapon that can be perceived as a threat, rather than a gunshot being fired. And we've been doing integration for a long time, 2 decades, which means that we are currently integrated with the vast majority, or at least a large portion, of emergency response systems that are out there, video management platforms, access control, other response protocols. We have dedicated integration through over 50 native integrations, as well as custom integration options, our APIs, both of the verification and the alarming layer, common formats like XML, EAS format, et cetera, webhook, the list goes on and on. It's really about operating in the real world. And in the real world, most of our customers have spent a lot of time, money, and effort on existing emergency response protocols. It's not about ripping and replacing. We're not trying to reinvent the wheel. As I said, we're here to uplift existing security teams and existing security practices, plugging in awareness and real intelligence at the beginning of that chain so that we can, as Chad said, move the needle, move it to the left, get ahead of the bang, start that most important minute of emergency response earlier in the process. So how does our process work? I'm going to highlight some testing that we did. We can't share a lot of live information out of the system, but I can highlight some testing that we did. A gun is exposed to the camera, and immediately that AI detects less than a second. Our clinical average is 0.36 seconds, I think. Chad, correct me if I'm wrong. But in real world, I see it takes about a second. As soon as that occurs, when that detection occurs, we start the process. We move that along. We get that information where it needs to be, to verification, to SOC platforms, to the folks in the field, so that they get that context, that image, that zoomed image, that location, and they can take action from wherever they are, whether that's confirming the alert on the app, whether that's speaking with a point of contact and saying, yes, please escalate, or whether things happen automatically based on previous workflows. It's all about operating in that real world, detecting a weapon in less than a second, verifying it seconds later, activating people and systems so that we can get that unified response out. Points of contact engaged, first responders en route, integrations triggered in seconds, not minutes, hopefully before a shot is fired. So I'll wrap it up here with a use case, and then, Ara, if we can open it up for a little bit of discussion with Kevin. Why does this matter? Well, it's all about shifting from a reactive security posture to a proactive safety system. We turn your passive cameras into active sensors so that we are aware of a threat the moment it appears. And that speed matters because when detections surface in seconds, we can start that emergency response earlier. And it supports our duty of care. It shows that we've taken a reasonable, proactive step to protect people. That's what a proactive safety system looks like. It's systematic prevention, not just optimism. And I think that we learned a lot of lessons historically when it comes to our practices and the technology and things that we put in place. The last century, school fires were one of the most serious threats facing the public, facing our students, our children. They weren't isolated incidents. They were catastrophic and tragically common. The problem was widespread and deadly, hundreds of lives lost across single incidents. What all those tragedies had in common was not just the fire itself, but the lack of preparation. The quotes from that era sound eerily familiar. They make it clear people knew these incidents were preventable. And yet many communities still believed they couldn't happen here. These events forced a reckoning. They showed that school fires were not just flukes. They were foreseeable, systematic risks that demanded a systematic solution. And, we did that. They prompted improvements in fire safety standards, including requirements of fire-resistant building materials, alarms, sprinklers, fire drills, evacuations, the list goes on and on. So much so that in the last 50 years, the number of fatalities that we're seeing on an annual basis, in most cases, is less than one. We made changes, and the results are we saw improvement. Relying on optimism or assuming that it won't happen here, it's inadequate when it comes to protecting lives. We need proactive, systematic approaches rather than passive optimism. After the multiple tragedies that we saw, the Collinswood school fire, Lady of the Angels school fire, the list goes on and on, we took action. And with the epidemic of mass shootings that we see in the US today, that is something that is predictable. And it requires preparation, investment, and systematic prevention. I'll finish up by saying, I speak about this product all the time on a daily basis, hundreds, if not thousands of times in the last few years. And people ask me all the time, has Omnilert actually stopped a shooting, detected a firearm outside of tests or demos? Well, I can't say if we've stopped a shooting because it's hard to prove the negative. Have we detected weapons where they're not supposed to be? Absolutely less. Yes, all the time. A sample 1 month snapshot from here is from August 2025. We detected around 50 firearms where they should not be in production environments, not staged, not pilots, not tests, real world incidents. And at this rate, we're on pace to detect more than 2,200 firearms this year across all of our deployment types: interiors, exteriors, rooftops, mobile trailers, parking lots, municipal transit systems, on buses. These span every sort of venue: parking lots, ticketing counters, indoor, outdoor. Importantly, of those 2,200 or so detections, about 2,000 of them will have gone through Omnilert monitoring, verified by staff with an average response time end to end of just under 10 seconds from the moment the frame is captured to a verified alert. And this real world performance is why we are trusted by some of the largest enterprise scale customers across retail, education, healthcare, distribution, transportation, stadiums, municipalities. The list goes on and on. At the end of the day, early detection can make a difference. And that's really what we're here for. Ara?
Absolutely. Yeah, thank you, Eric. And that's fantastic. I love seeing the actual statistics because we get asked all the time, does it actually work? In fact, somebody already asked the question in the Q&A. Please, if you have questions, we do have a bunch of questions in the Q&A now. One of the things I did want to reiterate, the role of technology when it comes to prevention, right? Technology is one component, and prevention starts with culture in the people aspect. To see something, say something. Most individuals who commit an act of violence are plotting. They share their information. They call it leakage with others, whether it's on social media, verbally or otherwise. And getting ahead of that and preventing an event from happening is absolutely critical. But when we fail to prevent an event from happening, now we need to detect a threat early on using technology like Omnilert Gun Detect to detect that threat and then automate response to that whole workflow to get people out of harm's way. And that's why this is a critical part of a multi-layered approach. It's absolutely critical. And that's where I want to talk to you about Dr. Kevin Eberle. I met Dr. Eberle through Zero Now, the school safety nonprofit that we're both involved with. And Kevin came in as a former school administrator, the chief operating officer of Buffalo Public Schools.
I retired a few years, been through a few years now. So as far as consulting and coming through and being a passionate leader all my years and thinking about safety, I started going into the areas of saying, hey, let's really talk about what a national plan is. What is a plan to make this systemic, where we really start looking at, how we can help every. And this isn't just K-12. I mean, this is houses of worship. This is hospitals, as Eric was alluded to. This is every venue, every community area. Downtown Buffalo right now, there's 4 or 5 schools right downtown Buffalo that all exit at the same time. they're definitely having issues there as far as population students going out. You want to have different elements to help you. And Omnilert, again, could be an actual excellent tool for that. So that's my background.
No,
That's where I really started with, and going into my passion for where I'm at with you, really. And I use it. Eric alluded to it too. He stole a couple of my words, but my mantra has always been. I had an international high school on the west side of Buffalo, Grover, Cleveland. It had 70 countries, 45 languages. Now it's up over 100 languages. And the theme there for international prep, I always said, we have to bring the world into focus. All these languages, all these cultures, all these things. And now I'm into the active prevention world where we have to bring awareness into focus. We have to have where teachers, administrators, students, every stakeholder, nurses in hospitals, rabbis in synagogues, priests, everybody needs to be personally aware of their surroundings. We say this, but do we really do it? And there's where I'm really going into where we start talking about leadership and really developing more leaders, and that everybody can be a leader in this, to have this focus on awareness of where we are and what we need to do to really help. And as you alluded to, Ara, it's all about a multi-layered approach. With technology that is in place, that can be in place everywhere, it's just an add-on to what we need to do as far as prevention.
Excellent, absolutely, and that's the whole objective is prevention. And like Eric shared, we did this with as a society, we did this with fire safety, right? When it came to almost ultimately eliminating fatalities due to fire, school fires specifically. We can do that with this case too. I think we're optimistic on that front, as Eric also alluded to, but it takes proactive measures. It takes a multi-layered approach to this, and that's why it's so critical to have detection and then automated workflows to be able to keep people out of harm's way, like a fire detection system, an alarm system, and fire suppression system. So we only have about 19 minutes left already, but we have a ton of questions, and I will tell you right now, we are going to have to email. We're going to get back to everyone on their questions, but just a few questions I want to get into, and either one of you are open to answer this. First question is, this is school related, probably because top of mind with Kevin's comments there in your story, Kevin. So our school has an ROTC program. Will Omnilert detect ROTC rifles and lock down the schools automatically? And Eric, I'll let you answer this because this plays into the whole element of context, human context, because the AI gun detection Omnilert is a tool for humans. But why don't you talk about an ROTC situation or even a prop gun outside of a theater?
Sure. Absolutely. So when you're talking about will the system detect, and the system, I think, is a big part of that answer. Will the system detect and escalate an ROTC rifle to the police? Well, the system won't, but the AI will. The AI, again, as Chad said, it's a filter. It's a tool. It has one job. It sees a gun and it raises it as an object of interest. We get that into the hands of qualified decision makers. The first layer may be Omnilert monitoring, but the second layer is our customers' decision makers, feeding them what they request. And we do have, programs in place to filter out known objects that are maybe of interest, gives them some color. This is an ROTC weapon. What action do you want to take, or no action? This is a weapon that is very obviously a toy, but because it's gun-like enough that it looks like a real gun, but it has that orange tip, we raise it. Because some of our customers, some schools have a zero tolerance policy. We don't even want something that is gun-like enough, an airsoft rifle, on our premises. And we are going to treat that as something that we want to respond to. Now, we may not respond to it by escalating to local first responders, but we'll respond to it internally, and we still want to know about it. So that's what it is. It is all about context, and it is about our customers crafting their response, getting the information that they need so that they can make their decision.
And can I add to that, Ara? That's an excellent point, Eric. But from the principal's perspective in the school itself, many of these things, when we go back to the concept of multi-layered approaches, it literally comes down to policies and procedures and leadership. I mean, I'll say this like a broken record. It really is about focusing on leadership and what kind of culture you want to build in your school. If a JROTC, and believe me, we have some incredible JROTC programs that, yes, they have the parade rifles there. that's part of the leadership and how you actually come back to that focusing on awareness and how that all lays into the layer of cameras and gun detect.
Context matters. That's critical. And the AI weapons detection, as you mentioned, Eric, is a decision-making tool. It does not make the final decision. That requires human. And then, as you said, Dr. Eberle, it's about protocols. What happens when there is a identified threat that is confirmed to be a threat that requires action? Having those protocols in place, having the right people trained in order to respond to those is absolutely critical. All right, we got some more questions here. We have a number of questions. I'll consolidate this into one. To clarify, can you detect a gun if only if it's in full view, if it's partially hidden, or if it's holstered? Will it detect it and then launch a response? Do you want to take that one, Eric?
When it comes to detecting a weapon, it's not about the percentage of the weapon that's visible. People always ask, how much of the gun do you have to see? And that's not really true. It's a combination of a number of factors: distance from the lens, number of pixels on target, the resolution of the camera. Do we detect a weapon only if it's in full view? No, but we do need to be able to see the gun. It's one of the reasons, one of the limitations of a visual weapons detection system. The weapon has to be visual. We have to be able to see it. We're not going to detect a concealed weapon, something in a backpack, something in a shoulder holster. We're looking for weapons in context. Specifically, when it comes to pistols, we're looking for brandished weapons, a weapon in hand. The system ignores holstered weapons, and there's a long list of reasons why. We've been out there operationally since 2019, and every single time a question has come up about, well, can we remove the holster restriction? Operationally, the decision is, well, let's put it back in place because uniformed officers, SRO, our security guards at our corporate campus, the off-duty police, we're in an open carry state. Well, we'll still detect on an AR-15 if it walks in, whether it's shouldered or at, in arms, because I think even in an open carry state, you want to know if an AR-15 walks on the premises. But we need to be able to see the gun. How much of the gun depends on a lot of things. How close to the camera, the type of weapon. But we've got a 90. Chad can correct me again if I'm wrong, 99.8% accuracy, which means when the gun is presented, we get it.
Right. I think that leads into some of the other questions I saw in there as well about what kind of cameras will it work with and what are the requirements for it to detect well. So as Eric mentioned, we need a certain number of pixels on the target, and you have to have enough pixels that the features of the weapon can be distinguished. So if you think of a camera, right at the lens, all the pixels are there, and the resolution is the full resolution of the camera. So a 2 megapixel camera, HD camera, is 1920 pixels by 1080 pixels, right? As you move away from the lens, though, those pixels get spread out, and the farther away that you get, the fewer and fewer pixels you'll have on the target, on the weapon. So for a 1080p camera, around 40 feet for a standard field of view, because it matters how wide the camera lens is. If you take the same sensor and you spread all those pixels out all the way to 180 degrees, you have to be much closer to the camera in order to get enough pixels on it. The metric we use is 40 pixels per foot. So if I take I have a weapon here because I'm a weapons detection engineer. Okay, so I have a weapon here. If I count the number of pixels I have on here, I have to have it. And this is about 6 inches, so I need about 20 pixels across. And we've trained it on all orientations, right? So that you can see it, whether it's upside down, right side up. But we are looking for weapons that are in a hand, not in the holster. We want to see the hand on the object. So even our security guards will have it in their holster, and sometimes when they forget and just put their hand on the holster, sometimes that'll give a detection. Again, though, we don't call the police directly when that happens. It goes to a human validator, and decisions are made based on context. Your cameras are in good condition, that they've been maintained, that they're clean. We can't see through obscurants. That's why we can't see concealed weapons either. We can't see through people's clothes. We can't see through dirt. So make sure that your cameras are clean.
Yeah, absolutely. We have a number of questions about like facial recognition or other biometric recognition. Chad, since you have the mic here, does the system use any sort of facial or biometric recognition to make the detections?
We do not. No biometrics whatsoever. We're looking for inanimate objects. These things. This is what we're looking for, and it doesn't matter whether it doesn't matter what your skin color is, doesn't matter who's holding it. We don't even look at facial features whatsoever. We use the detection of a person to define our areas of interest. And that's where, once we have an area of interest, then we scan at the pixel level for weapons.
A lot of concern about privacy and security. And we do have our DHS Safety Act designation. We are deployed in hospitals, in K through 12 institutions, in locations that are very privacy conscious. Because we are not using any PII, we're not storing any facial recognition data, we're not looking at anything like that. Getting through those sorts of requirements is fairly easy for us.
Another question here. How far away can a detection occur on a camera? We have cameras that are mounted 20 feet in the air in some cases. We have others as well. So does the distance impact the ability to detect a firearm?
Yeah, and that's what I described with the pixel density. So the farther away from the lens you are, the lower your pixel density. And we need at least 40 pixels per foot wherever the weapon's being detected. So you can increase the distance that you can detect something at. If you have you can detect something 1,000 feet away. If you have the right lens on your camera and the right resolution, and you have enough light 1,000 feet away, we've demonstrated that, no problem. But in practical situations, mounting your camera around 10 feet is a good place to be, because you can use lower cost, lower resolution cameras. If you need to be 100 feet in the air, we can do that. We just need to have a conversation about what camera is required in order to do that.
It is all about using the right camera for the job. As an example, 1080p camera, typically standard field of view is going to get you about 40 feet of detection from the lens. Perfect for indoors, in an office, in a hallway. You're probably not going to want to put it on a light pole 20 feet in the air looking at your parking lot. 4K or 6K might be perfectly. Conversely, a 720p camera probably has about 15 feet of throw at a standard field of view. Might be great for an entryway or a vestibule, or parked right above the door so you can catch people as they walk in. But again, not something you're going to want to put in the cafeteria, on the exterior of a building. It's all about using the right camera for the job.
We have a few questions about detecting realistic toy guns versus real guns. Does a system detect toy guns?
Representative weapons will get detected by the system, and that will get passed to the human validators. And then you get to decide whether or not that's something that you want to take action on.
I think one of the questions that came in earlier kind of revolved around, I think there was part of the demystifying on gun detection is that a gun is detected, then it automatically calls the police. And just want to reiterate the human in the loop process. And in fact, there's more than one human in the loop during a typical process. You have the detection, you've got the verification that this is in fact an object of interest. Let's send it off to the customer, who might have additional context cues. But if it looks like a gun to a human eye, it will be sent for final determination. So just want to verify, just make sure that that's crystal clear. Let's see here. Once a threat is detected, and Eric, this is right up your alley. Once a threat is detected, how customizable is the response workflow, and how do you keep teams to avoid alert fatigue?
It is a very customizable workflow. From end to end, the path isn't always the same. It's similar. We detect a weapon, it's verified somewhere, and then action is taken. But there are multiple steps along that. If it's going to Omnilert monitoring, there are also multiple integration points. We can spawn integrations right after the AI detects a weapon, right after the monitoring agency confirms or shuts it down, right after it gets into the hands of your team and it goes to an escalated status, right after that public safety answering point integration, the PSAP integration is triggered. So the different permutations of that there's a lot of them. We also don't have to go through Omnilert monitoring. We also can have Omnilert monitoring only facilitate the escalation. It can go directly to a customer team. They can make the designation and either shut the alert down or escalate. When it escalates, we can do more. It is, as I mentioned before, we've been doing emergency notification for a long time. And we learned a long time ago that a K-12 is different than a college institution, is different than a manufacturing facility, is different than, so many other things. Every organization's different. Every organization has policies that work for them. We need to integrate into those workflows. Now, when we talk about alert fatigue, cry wolf syndrome's real. I've been talking about that for almost 20 years. If we alert too often, people get desensitized to it. The Omnilert system is not noisy. It's very low in noise. We, at last count, I believe, and I might have a decimal place wrong, I believe that if you've got 1,000 cameras, and we've done that tuning that Ara talked about, removing any of the out of there detections that might happen because of environmental variables. Our system throws about 0.1 alerts per day per 1,000 cameras, and that includes legitimate detections, and that includes the occasional spurious detection, a benign object that's mistaken for a gun, or a gun that's not a threat, a toy, a prop, what have you. And that's system-wide. So the system is low noise. But if you're an organization with, let's take a hospital, for example, 2,000 cameras, how are you going to otherwise look at those cameras? When people plug in our system, they're surprised at what they get back. Even if it's just their local security guard taking his gun belt off in a hallway and pulling his gun out and putting it down on the table next to him. I've seen it. The detections happen. It is low noise. So alert fatigue really doesn't become an issue.
Let me just talk to alert quality for a second, because I did design the system with the same mindset that I was designing a rocket-propelled grenade detector. Like, we cannot have a false alarm. That just cannot happen. And the way that we prevented those and have reduced our false alarm rate while also increasing our probability of detection is a carefully crafted and curated data set. So AI is extremely dependent on the data that you give it to train off of. And I didn't go into this in too much detail, but the way that you tune an AI system is you give it new images to work with. So whenever we do, in the past, when we first started up the system, we would get some false alarms, and we would take that image that it false alarmed on and feed that back through the training procedure until the system did no longer false alarm on that object. So I think you are off by a decimal point, Eric. We did a study with 10,000 cameras randomly sampled from our total database. And we looked at how often a phone call was made from Omnilert monitoring to the customer. And it's around 4 per week. So this alert fatigue is really not a thing.
I wanted to share with our attendees today because, we're talking about this stuff. Awesome. Eric showed you some video images and clips and all that. But we want to give you an opportunity to try it yourself in your own environment, whether it's a school, house of worship, a corporation, retail, manufacturing, doesn't matter what it is. It's always good to try it out for yourself. So what we are going to do is, because we say, hey, here you go, here's a free box, you just sit in the back there. But what we're doing here is, because you're registered for this webinar, if you schedule a demonstration before the end of this year, and then if you make a purchase of even one appliance, which can cover between 20 and 40 cameras, depending on the level of quality of your cameras, by the end of March of 2026, there will be a 15% discount off your initial offer, because we want you to try it firsthand. We are out of time. As I mentioned, we have a lot of questions. I mean, it seems like there's 100 questions that came in. A lot of them did cover a bunch of common items, but we will respond to those questions. Thank you, Chad. Thank you, Dr. Eberle. Thank you, Eric, for taking the time today. Take everybody, stay safe, and have a happy holidays. Take care.